Welcome to Math 2320, Section 8.3. We're looking at solving a system of differential equations using matrices and the method of undetermined coefficients. So here's our first particular system. So we take the part that is the matrix, so 2, 3, minus 1, minus 2. We look for the eigenvalues. So I look for the determinant of a minus lambda I equals 0. And so that's what we did here. Downward diagonal minus the upward 1. All right. So 2 times minus 2 is a minus 4. Got a minus 2 lambda plus 2 lambda and a plus lambda squared plus 3. Minus 2 lambda parts cancel and I get lambda squared minus 1, which easily factors into lambda minus 1, lambda plus 1, giving me the eigenvalues of 1 and minus 1. Alright, I need to find the eigenvector that goes with each one. Alright, so for lambda 1 equals 1, it's a minus I. So here's A. A is 2, 3 minus 1 minus 2. So subtract 1 from the elements on the diagonals. All right. Now in this case, my row operations, I can simply add the two rows together and we're done. X2 is free. X1 is 1 equals minus 3x2. And so I get minus 3 and a 1. All right, for the eigenvalue of minus 1. All right, so that's really a minus a minus, so a plus 1. So I'm going to add 1 to everything on the diagonals. In this case, it's pretty easy as well. Divide this row by 3, and then add row 1 and row 2. And so I get x2 is free, x1 is minus x2, and so I get minus 1, 1. So my homogeneous solution is of this particular format, where the eigenvalues are on the powers of e. The eigenvectors form the front part in front of the e's. Alright, so now we use the method of undetermined coefficients. I'm focusing on the right hand side here, my driving function area. I see that they're just constant, so my choice for a particular solution is A and B. Plugging this into both of the equations, the derivative of A is 0. All right, 2 times A plus 3 times B minus 7. All right. So now I need to clean it up a little bit and make it into a system of two equations and two unknowns. So that gets us to here. So now I think I'm going to get rid of the A's. So I'm going to multiply through the second equation by 2. All right, so doing that, I get minus b is minus 5, or b is 5. All right, well, I have 2a plus 3b is 7. Fill in what I know about b. 5 times 3 is 15. And so now I can solve for a, and a is minus 4. And so my full solution then is the homogeneous part plus what we got from our particular solution of minus 4 and 5. So you could write it this way, or the solution writes it that way. All right, and then there was the details for solution 1 for that the WebAssign provided. All right, question 2. All right, we have our matrix A here. We have our driving function on the right-hand side. So I'm looking for the eigenvalues of matrix A. All right, so find the determinant of a minus lambda I. So subtract lambda down the diagonals. Find the determinant. All right, so I get 4 times 6, get a minus 4 lambda, a minus 6 lambda, a lambda squared, minus 3. So cleaning this up to get the characteristic polynomial, which is factorable into lambda minus 7, lambda minus 3. And so I get eigenvalues of 7 and 3. All right, looking for eigenvectors. All right, so that's a minus 7i. So let's see, 4 minus 7 is a minus 3. 6 minus 7 is a minus 1. The other parts stay the same. All right, so I'm simply going to multiply the row 1 by 3, add it to row 2, and I get a row of all zeros. So that says that x2 is free. Now what about this? Minus 3x1 plus 1/3 x2 is 0. So multiplying through by negative 1 and moving this to the right, I get that x1 is 1/9 x2. So you could use 1/9 and 1, or getting rid of the fraction, multiplying through by 9, I get 1 and a 9. All right, for lambda equals 3, a minus 3i. All right. So let's see, I'll multiply this row by negative 9 and add, and again I get a whole row of zeros quickly. So x2 is free, x1 is minus 1/3 x2. So cleaning this up so that we make it with whole numbers, multiply top and bottom by 3, and so I get minus 1, 3. So for our homogeneous solution, I've got the eigenvalues on each of the e's along with the eigenvectors in the front. So now looking at the driving function on the right hand side, I'm going to look for a particular solution of the form a e to the t, b e to the t. All right, filling this in, the derivatives here don't change. They're just a e to the t, b e to the t. And I'll just fill in all the way across. Now, all of these terms have e to the t in it, and so I'm going to divide by e to the t. Now, I can do that because e to the t is never 0 for all possible values of t. All right, so our system begins to take shape here. All right, so I need to bring the a over. So 4a minus a, I get a 3a. Move the minus 3 to the left. Let's see, 6b minus b is a 5b. Move the minus 2 to the left. All right, so looking at this, I'm thinking I'm going to get rid of the a. Multiply this one by minus 3 all the way across. Add them up, so they're gone. 5 minus 1 is a 4, so I get b is minus 11/4. All right, so I'm going to take this top equation here, and I'm going to fill in my minus 11/4. So I get a 3 plus 11/12. Well, 3 is writable as 36/12, so 47/12. And now multiply through by 1/3. So putting all this together, we have our homogeneous solution, eigenvalues, eigenvectors, and then our particular solution is of the form e to the t, and these are the different coefficients in the front. All right, let's see. In question 3, we have our matrix A, our driving function, we're going to use undetermined coefficients. And in this case, they're giving us some initial conditions. All right, so we start off, and I'm looking for the characteristic polynomial. So form my determinant. Minus 1 times minus 4, I get a plus lambda minus 4 lambda. Lambda squared plus 6 equals 0. All right, so cleaning this up, I get lambda squared minus 3 lambda plus 2 is 0, which does factor, and this factors into lambda minus 2, lambda minus 1. So, eigenvalues of 2 and 1 for matrix A. Alright, so with lambda equals 2, I need to find A minus 2i. So I'm subtracting 2 from each of the diagonal elements. Alright, well this is really pretty easy. I can just add them together, get a whole row of zeros. So x2 is free, x1 is, bring the 2 over, minus 2/3 x2. And so I can leave it like that, or to get rid of the fractions, I can multiply top and bottom by 3. And so this piece of my homogeneous solution looks like minus 2, 3, e to the 2t. All right, use the eigenvalue of 1. So I'm subtracting 1 down each of the diagonal elements. All right, so I can divide row 1 by negative 2 and then multiply it by minus 3, and I quickly get a whole row of zeros. So x2 is free, x1 is minus x2, so I get minus 1, 1. And so that gives me minus 1, 1 e to the t. Now for some reason WebAssign chose to write it as 1 minus 1, which you can get simply by multiplying the top and the bottom here by negative 1. Still works because you can multiply this item by any scalar that you like. And so where we're at so far now is here's our homogeneous solution. Based on this driving function, I'm picking A, B as my particular solution. Plug it into my system. The derivatives of A and B are each 0, and then filling things in. And so I get my system of equations to solve for A and B. Alright, so I'm going to multiply the top row all the way across by minus 3, add them up. So I get a minus 2b equals minus 8. Or I get b is 4. So plugging this into this equation, I get a plus 2 times 4 is 2. And so I get a is minus 6. Alright, so far we are down to, here's my homogeneous solution plus my particular solution. Now we need to get into the game the initial conditions. Well, e of 0 is just 1, so that's not present. And so I get minus 3, 6, c1, minus 2, 3, c2, and so on. So let's get it out of this format into something we can handle. Let's see. I've got a minus 2c1. I've got a minus c2 constant. Let's see. Minus 6 comes across. 2e is 6. 6 minus 3 is 3. 3c1, c2. Bring the 4 over. 6 minus 4 is 2. Alright, let's see, I can just add it up like it is, and C2 goes away, and I get C1 is 5. So plugging this into the bottom one here, I get 15 plus C2 is 2, or C2 is minus 13. All right, so filling this in, I could write it in this format. Here's 5, here's my minus 13. Or if you wanted to multiply in the minus 13 in, you could also write this as 13 with a 1 and a minus 1. All the same thing. And that concludes section 8.3.